Okay, this week we are going to be doing inequalities. So we're moving on from quadratics. You guys got exposed to the quadratic equation or quadratic formula a little bit, so you've seen it. So when you get to Algebra 2 and geometry, you should know how to plug your numbers in just to be able to find what you need, and then you also know how to factor. So now we're moving on to inequalities. Okay, these are just from your homework. So I'm going to do the first 4 for you, and then I think you have 4 after that to do. And then we're going to do a different type of problem, and I'm going to do the first 4, and I think you have a few after that to do. So just a reminder, this stuff is actually stuff from 6th and 7th grade, so I'm going to use this just to remind you guys about what inequalities mean, and then we're going to move on to this stuff that should be a little bit new for you. So if it says less than or equal to, that equal sign means that you're going to have a closed dot. If it just says less than, you're going to have an open dot. And that's because if it's equal to, that means it's included. If it does not say equal to, that means it's not included. So in this case, on this first one, we have an open dot. So with that being said, we can cross out all of these that say equal to. So we already know it's not B and it's not D, because an open dot means that it's not included, so it's not going to be equal to. Now we have to decide if B, so B would be right here. Is B greater than 2, or is B less than 2? B is greater than 2, so we're going to say B is greater than 2. So that would be option A. Now the second one, we have a closed dot. If it's closed dot, we can get rid of B already because it's not equal to, and C because it's not equal to. Now K is right here. So is K less than -1, or is K greater than -1? It's this option. So this would be less, and this would be greater. To the right is always going to be greater, to the left is always going to be less. So we would say K is less than or equal to, because it's a closed dot, -1. So that would be option D. Okay, now we have an open dot again. So we know it's not going to be equal to, so it cannot be B or D. And this is where N would be. Remember that to the right would mean greater. To the left would be less. And it's this one to the right. So we would say N is greater than our number, which is -3. And it's not equal to, so we don't have a line underneath it. So this would be option C. Okay, we have an open dot again on 4, or a closed dot again on 4. So a closed dot means it's equal to, so it cannot be, it could be any of these ones on this one, because they are all equal to. So B is here, and we know we're going to have -4. So we're going to say, is B greater or less than? So it's this option that's less than. So we're going to say B is less than or equal to -4, which is option D. So it's always the number you're at. So it's not going to be +4 because we're not at +4. +4 would be over here. Okay, now we're just going to be doing graphing inequalities still, but these are linear inequalities. So you're going to be given a linear equation, but instead of an equal sign, you're going to have an inequality there. So when you do these, you're going to just graph the linear equation. And then you're going to test the point. Which you'll see what that means. Before we do this though, just like you have open dots and closed dots with the other ones, a dotted line means that it would just be less than or greater than. A solid line, and these are always going to have arrows on the end still, just like a linear equation. A solid line would be less than or equal to, greater than or equal to, or just equal to, just like we're used to graphing linear equations. So let's just graph this first, and let's pretend this is just y equals negative 3/4 x plus 1. So we would graph our y-intercept first, which is 1. We would go down 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Now, this says just less than, so that means we're going to have a dotted line. So when I go to connect this, I'm just going to make it a dotted line instead of how we would usually do a solid line. So I guess I'm going to add one more step in here. Dot or solid. So we graphed our equation, we did a dotted or solid line. Now we need to test a point. So when I say that, you're just going to choose some x value. You don't really want to choose an x value that it goes through. So see how it would go through 1 right here? We don't really want to choose that one. So we're just going to choose an x value and see if it works for y. So let's go ahead and choose just 6 over here. So if this statement is true, and I choose x to be 6, then we're going to shade in that region. So I'm going to show you what that means. So we have y is less than negative 3/4 x plus 1. So we're going to plug our value in for x first. So we have negative 3/4, and now we have 6 plus 1. When you guys do this, go ahead and just put this in your calculator. So do negative 3/4, then times 6, and add 1 to it. And when you do that, you should get negative 3.5. Okay, so now I have to decide what my y is going to be. So if I choose 6, I'm just going to draw this line in here for now. So if I choose 6, I want to choose something that's on this side to decide if I shade it on this side, and I want to choose something that's on this side to decide if I shade on this side. So I'm going to choose 6, 0 for this side. And something over here would be 6, negative 7. So those are my 2 points on my other sides of my lines. We already plugged in 6 down here. So now we need to decide which one of these is true. I'm going to erase this because we don't really need it anymore. So is negative 7 less than negative 3.5, or is 0 less than negative 3.5? This one would be true. So this is the part where it's different than just graphing a regular linear equation. We are graphing a linear inequality now. This bottom point was true, so that means I'm going to shade this bottom part in on this graph. So this whole bottom part is actually a solution to this linear inequality. And I'm going to erase this because we don't need it anymore. If the other one would have been true, if my point up here would have made it true, I would have shaded the top in. So we're going to do a couple more so you guys can see what this looks like. Okay, so let's try another one. Remember, the first thing we're going to do is just graph. Then we're going to decide dotted or solid. And then we are going to choose 2 points. And then we're going to shade. Okay, so let's start with just graphing y equals -3/4 x plus 4. So we're going to have 4 as our y-intercept. Then we're going to go down 3 and to the right 4. Now if we go back to our equation, remember that dotted line means less than or greater than, and a solid line means less than or equal to, or greater than or equal to, or equal to. So in this case, we have y is less than or equal to, so it's going to be a solid line. Now we need to choose 2 points. So I'm just going to choose this point here and this point here. Notice how they're on opposite sides of the line. So I'm going to test this top one first, which is 7, 7. So we're going to see if that point makes this true first. So we have y is less than or equal to -3/4 x plus 4. And I'm going to see y, my y right here is 7, right? This is my y. This is my x. I'm going to see if 7 is less than or equal to whatever I get over here when I plug 7 in. So if I plug this stuff in on the right hand side of here, I should get -1.25. Is -1.25 greater than or equal to 7? It is not. So we are going to say that point doesn't work. So we already know we're not going to shade the top, we're going to shade the bottom. However, when you do these, you should test both points just to confirm your answer, because if we get the wrong thing for the bottom one also, then we messed up somewhere. We need to check. Okay? So this one is -4, -6. So we're going to see if -6, because that's our y, remember this is an xy order pair, is less than or equal to -3/4. We're plugging in -4 for our x, and then plus 4. And when you do that, you should get 7 here on the right hand side, and then we still have -6. So is -6 less than or equal to 7? It is. That means this works. So that means we are shading in this bottom region. So the reason we do this is because our solution can be anywhere in that shaded region or on that line, because the line is also included. If we look at the last one, our solution can be anywhere in that region, or it cannot be the dotted line on this one because it's not included. That's why it's a dotted line. It's not an included solution. So it can only be in that shaded region. Okay, let's try another one. So remember, we're going to graph. We're going to decide dotted or solid. We're going to test 2 points. And then we're going to shade. So remember, we just graphed y equals 2/5 x plus 2 first. So we're going to start at 2. and we go up 2 and to the right 5. Now we need to look at this and remember dotted would be less than or greater than. Solid is less than or equal to, greater than or equal to, or equals. In this case, we just have less than, so this is going to be a dotted line. Now we need to choose 2 test points. When you guys do these, you don't really want to choose something that's like right up here, because it could just be our line was drawn off. You want to draw or choose something that's very much so in that region. So this is in the bottom region, and this is definitely in the top region. So we're going to use 6, -2, and we're going to use 6, 8, and see which of them works. So we're going to have -2 is less than 2/5, x, which are x, whoops, I'm doing this one first, by the way, sorry guys. Our x is 6 in that case, and our -2 is our y, right? And then we have +2. I just plugged it into this equation. Now we're going to see if that is actually true. Okay, if I plug that stuff on the right-hand side of my calculator, which is what I would suggest just doing, you guys, because it's not like this work is work I'm checking or that you have to be super accurate on and have a fraction. This is your own work to figure out where your shading is. So if I plug that into my calculator, I get -0.4. And we can see that -2 is less than -0.4. So we should be shading that bottom part. But let's check our answer just in case by testing that first point up here. So we're going to have 6. Whoops, not 6. Our y is 8. Remember, it's y is less than 2/5, x plus 2. So our y is 8. Then we have less than 2/5. Our x is 6. And then we have plus 2. So we know that this is -0.4. And 8 is not less than that. So we know that this is the right one. So we're going to shade the bottom region. And this would mean that our solution can be anywhere in this shaded region, and it cannot be on the line because it's a dotted line. It's not included. Okay, this is the last one we're going to do. Remember, we want to graph y equals -9x plus 5 first. So we're going to have 5. And we go down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And to the right 1. Because remember, -9 over 1 just equals -9. And this is not equal to, so we are going to have a dotted line. Now see how my line is not completely straight because I'm obviously freehanding this. That's why you want to make sure your points are clearly in the regions that you're testing them in. So I'm going to test this point right here. That is clearly in that region on the far right. And I'm going to test this point right here because it's clearly in the region on the left. There's no mistaking it. It couldn't be that I drew my line wrong. It's clearly in that region. So this is the point 6. 6. And this is the point -6, 4. So we need to test those in our equation. So remember, we have y is less than -9x plus 5. And in our first case, we're using negative 6, 4, and on the other one, we're using 6, 6. So we're going to have 4 is less than negative 9 times negative 6 plus 5. Negative 9 times negative 6 is 54. 54 plus 5 is 59. 4 is less than 59, so this does work. So we should be shading in this region, but let's just check our answer just in case by testing the other point. So we have 6 is less than negative 9 times 6 plus 5. So we would have negative 9 times 6 is negative 54. Negative 54 plus 5 is negative 49. And 6 is not less than that, so this does not work. So we are going to be shading on this side. Okay, this is the last one that I'm going to help you guys with. This was actually problems 11 through 14 on your homework. So not all of those are homework, just some of them. I think I left 6 of them for you to do, so I did 4 of them for you. If you have questions, make sure you email me and ask me questions. If you're struggling with graphing linear equations, you can ask me for help. Or on YouTube, if you look at Patrick JMT and search graphing linear equations, he has some really good videos on graphing linear equations. I know some of you guys are 8th graders that skipped 8th grade math, which is mostly what 8th grade math is graphing linear equations. So if you need some extra help on that, you're more than welcome to ask me for help. But also if you want to check out his video on graphing linear equations, you can do that too. He makes pretty good math videos. So go ahead and work on these, and next week we're going to talk more about what those solutions mean. So like on this one, we would say that our solution is on that left-hand side, that shaded region, and it wouldn't include that line. We're going to talk more about what that means next week.